Hey everybody, it is Volcanoes week, I record these on Friday, so I got my ISU t-shirt on, and I think you guys know I've got it on my coffee mug that I carry here and there. I've used a few times in these videos. Our motto is gladly we learn and teach. I married a teacher, and so we have been doing plenty of learning to try to change how we are teaching you guys. So similar to what I've done in past weeks, I'm going to bring the objective up in front of me in just a second as I read it. But then I'm going to provide you with, in your HyperDoc this week, some specific spots within the video where you can actually find specific parts of the lesson you might be looking for. It's a thing that Mrs. Newham has been looking at called Microteaching, and so it focuses on, instead of giving you the full like 10 or 15 minutes of stuff, getting you the chance to just focus on those individual pieces that you might actually need. So I'm trying it out. We're always trying new things. Let me know what you think of it. And so our objective for this week, I can describe the types of volcanoes, including details of the different styles of lava, flows, eruptions, and shape. I can demonstrate understanding of volcanoes on Earth and on different planets. I can create visual representations and or written explanations of types of volcanoes. And as I mentioned in one of the vlogs from last week, if you think that things would be easier if you are just told what to do, then go ahead and go through your choice board and do the pre-test, the checkpoint, and the test, and any learning you do along the way based on your grade on the pre-test. That's what I recommend for you. This week in the intro, I mentioned I'm trying something a little different called micro-teaching. And so along that line, I want to go ahead and post here. I'm going to jump out of the way so that you can see the timings of the different parts of this lesson. Best of luck. Okay, we got several vocab words. I'm going to sit over here to the side so I can put them up here on the white part of the screen. Lava that erupts from a cone volcano is going to be thick and pasty. The cone volcano is the traditional one that we think of, where it goes. So that's going to be the thick and pasty kind, cone volcano. A volcano erupted in Iceland. Who are we going to send to study the effects? Well, we have a bunch of different scientists that are possibly available. IST is going to be our type of scientist. It's a volcano. We're going to send a volcanologist. So let's see. What happens when gases build up and can't escape out the top? That is when we get a cone volcano. Spot where volcanoes develop even though there's no plate boundary. It also could be not just volcanoes, but hot springs like you might see in the western United States and especially across Japan. And kind of gives that away with the fact that hot springs can happen there. It's a hot spot. And then the chambers of a volcano that allow gases to escape. Quite simply, that's going to be vents. It's also the same thing that allows the air to escape in your house. You got vents in the floor going room to room. And then a non-violent dome-looking volcano that has thin, runny lava. That's going to be, so it's dome-shaped. Think of Captain America. I wore my Captain America shirt earlier in the week. It's going to be a shield volcano. That's what you're looking at with that. Thanks so much. Okay, we're going to look at differences here. We got two things covered in the volcanoes unit that have a difference. And both of them are similar to each other. The first one is magma and lava. And I think the best example for this would be for us to actually take a look at the sink. So we're going to run over here. Magma is just the water. There's water right behind here, okay? You can't see it yet, but that's the magma. It's the lava inside the earth. And now the lava, boom, that's the water coming out right here. When it comes out, lava. When it's inside, holding back, magma. Okay, our other difference question is about a dormant versus an extinct volcano. There's also active volcano, which means that it's one that is currently erupting. But when they're just sitting there, like this bumblebee doll is sitting here, they could be dormant or they could be extinct. And so extinct is if I turn our poor bumblebee upside down. Bees don't fly upside down, and so now she is dead. That's going to be extinct. Whereas if she's simply dormant, well, let her speak for herself. If you couldn't hear, she was saying it's sleepy time, time for sleep, lay down your head. So a dormant volcano is simply sleeping. Dormir is actually the French word for sleep anyhow. That's why colleges have dormitories.
And for this one, this is our basic sign of the field volcano. You can see where it flows over the sides. Simple, more liquidy lava flow. And we used this example in class of the toilet having an issue and just kind of overflowed all over the floor. Did leave the sound on this one because all right, so this video should be familiar. This is looking at how a cone volcano would work. Here at the start, if we look very closely at these little fountains, this is going to be more that cinder cone where it just kind of has the stuff kind of popping out. Not so much the full lava flow of the bigger cone that we are more used to. So let's take a look at what that bigger cone would look like. I'm going to go mute this. Okay, so that's everything coming out like that. Obviously, a little bit different concept.
Okay, so we're going to take a look at a couple of examples outside of my deck of what these actually look like. The cinder cone volcano, it's pieces of lava that are called cinders that are kind of blown out, and we're going to see stuff blowing around when we go outside in just a second. And then a composite cone volcano, it's made up of a mixture of lava flow and cinders. And so for that one, we're actually going to light something on fire. You see flames flying out all over the place and kind of see what that one looks like, because it'll still have the smoke and the cinders flying around as well. Okay, so for this next micro lesson, this section here, I thought I'd step outside by the barbecue and go ahead and take a look at a couple of the different kinds of lava flows, how those different volcanoes might actually look. So I'm going to do a couple demos on that, and hopefully it helps it make sense to you. Okay, first off, we're going to just go here inside the grill, and as I use my little ash sweeper, you can see, you know, ash is flying away. You can see my ash sweeper broke. I actually bought a new one. So ashes were flying away there. That is going to be kind of like your cinder cone. It's just got the stuff kind of blowing out and blowing around all over the place. Let me give a little bit further example of that by lighting some newspaper on fire here inside the grill, so we can get a better understanding of that. All right, so inside the charcoal chimney, there's a little grate inside. I don't know if you can see it, but so this newspaper right now is kind of held underneath the grate. You can see our cinders blowing around again, our ashes blowing up, and so this is going to imitate what that cinder cone would be like. Just got some ashes blowing around. We can see smoke coming out of it. So we can see the smoke coming up here. And then this paper would actually kind of throw off some cinders as well. That's what that cinder cone is going to look like. Now I'm going to add a bunch of more newspaper so we can actually see the flames shooting out the top, like in the Buckingham Fountain example. And you'll see how the lava would flow in a full composite cone. Okay, so if there is more flammable material in our volcano, we're going to see that it's actually going to burst out smoke at first, which we know about for our cinder cone. The composite cone is a combination of the cinder and the full lava flow. So you can see here now we're getting flames. They're coming out because of the wind. They're blowing around, but if it was a volcano, they would be kind of flowing over the sides of that charcoal chimney. And so this is what your full composite cone would look like as compared to that cinder cone. All right, for this week, if you are taking a look at choices 1 or 3, you're going to be asked to do some writing. And so I did want to do a quick review of, I'm going to slide out to the side again, write it on the ceiling, CER, and kind of review what those things are real quick. C, of course, is your claim. And so it's literally going to be based on the information that's provided, what makes the most sense. It's not necessarily what you specifically agree with. So, for example, if I go back to this past NBA season when it was actually playing, my claim would be the Bucks are the best team in the Midwest. The Milwaukee Bucks were the best team in the NBA this past year. And so even though I'm a Bulls fan, the Bucks are going to be the best claim. So you're going to go the best claim based on the information that's provided. How do you support that claim? You support that claim with evidence. That's what the E is in CER. And so that evidence is going to help you explain your claim. And so if you're doing either of option 1, the quiz, or option 3, the research essay, you're going to want to have some evidence that supports your claim as you're writing out those paragraphs. It's got to be actual information. You can't just make it up. You can't fake the evidence. You can't change the evidence to kind of make it fit what you're trying to say. You have to use actual information. So for my Bulls example, then I'm going to be saying, the Bucks were the best team in the NBA, and they had, this many wins. I'm not looking at their schedule right now, so I don't remember specifically. And then reasoning is simply explaining how that evidence supports your claim. So if I go back to my Bucks example, now again, you're going to be writing about Volcanoes. This is the Volcanoes unit. But if I go back to my Bucks example, my reasoning is going to be like, them having the best record shows that they are the best team in the Midwest because Milwaukee is in the Midwest. They have the best record in the whole NBA. So that's going to be a reasoning that actually explains how my evidence supports my claim. And so that's kind of your reminders of CER stuff, for if you're doing either the Google form quiz, there's a CER at the end of that, or the research essay about volcanoes and other planets, and to help you out with those things. Some of you, I imagine, went ahead and watched this video start to finish the same way you would any week. You didn't take the micro lessons option, which is totally fine. I wanted you to have options on this, and that's why I provided those checkpoints of where you could find different parts of the lesson. But I did want to go ahead and touch base at the end here. If you watched it straight through, thank you for watching. And as I typically have been saying at the end of my daily vlogs, take care of yourself and each other. Stay safe. Wash your hands. From my household to yours, we love you. If you have any questions this week on any of the information, please do reach out. Office hours Tuesday morning, drop-in hours Tuesday morning, 10:30 to 11:30. Drop-in hours on Thursday afternoon, 2:30 to 3:30. And of course, you can always reach me by email, text, or Google Hangouts chat. Best of luck this week with your information on volcanoes. I'll see you again digitally on the YouTube vlogs. Thanks so much.